Hello everybody and welcome to section 2. We're going to be covering subsidence here, or subsidence. It does not matter how you say it, really, I promise. Just pronounce all the letters and you'll be fine. So we'll have our little mental model here, our example setting scenario for this. Have a pumping well, which is extracting groundwater, and we see as a result of it taking water out of the ground that there is this drawdown of the water table. Essentially, we have this huge amount of vertical area here, which would normally be supported by water, but which is now supported by air. And as a result of the weight of all the ground materials now being supported by air, which does not do a very good job compared to the water, you could see this vertical sinking of the land surface, just literally moving downward over time. And just to illustrate, this is an example from the San Joaquin Valley in California. We can see there's been a total of, see it here, about 9 meters or about 30 feet of subsidence across about 50 years here. And there's this fellow here, let's just say he's kind of tall, about 6 feet. You'd have 1, 2, 3, 4, 5 of him across roughly 50 years. So one of him a year. This is pretty difficult to imagine, but the entire valley, the entire land surface, all the stuff on it would have been way up here back in 1925. It has fallen 30 feet straight downward in about 50 years. So what are we talking about exactly for subsidence? Well, the first thing we're talking about are the first two numbers in the axis code, which are 2, 6. So this is our gradual settling, or sometimes not so gradual settling, of the Earth's surface due to some sort of movement of Earth materials underground in the subsurface. This is something that happens worldwide. The United States specifically have about 17,000 square miles affected by it, roughly the size of New Hampshire and Vermont put together, which have been directly affected by subsidence. So not counting any of the complicated consequences of any of those effects that are just directly and sinking down, like we saw in the last slide. In about 80% of cases, this is caused by extraction of groundwater, pulling and pumping water out of the ground, and then the subsequent compaction of all the ground material which was above the groundwater. So in Arizona specifically, where is this happening? See, we're mostly looking at the southern part of the state, something which has been observed to be happening since the 1940s. We have a dramatic increase in the amount of pumping which went on in the state. With about 25 areas total, have just the bigger areas on the map here. You see actually up to 20 feet of subsidence measured here in the west to northwest Phoenix metro area, and up to 6 feet here in sort of northeast Scottsdale area of Phoenix metro. So just another example in Arizona to illustrate. Of course, no, this is not me. I'm sorry to disappoint you. I could never be this cool. You can see up in 1969, right, and it has fallen a full 9.7 feet since then. So we have roughly 10 feet of total subsidence here in Arizona. Not somewhere far away, affecting you, right? See Highway 10 is happening pretty close to you in Arizona. Something good to know about. Next session is going to be covering a little bit more of the geology of it. We're going to be covering caves, caverns, and sinkholes. Stay tuned.